Hello, everyone. Thank you for joining in. Welcome to this session on Hank and Meandro. Brujo is going to give us a session on the Oxbow code detectors for Erlang and Elixir. So without much delay, Brujo, over to you.
Okay, let's go. So, hello everyone. I am Brujo Benavides. I'm going to show you two tools with the same purpose but built for different languages. Hank for Erlang and Meandro for Elixir. They are static analyzers that will help you find and remove Oxbow code instances from your project. Let's start the conversation exploring what Oxbow code even is. And we will do it with an example. I will mostly use Hank and Erlang code in this presentation because that's what I'm most familiar with, but all the underlying principles apply as well for Elixir with Meandro, and the basic concepts apply as well for any other language, functional or otherwise. All right, let's start with a quick example. What you see on the screen is a simple module, but let's pretend that it's part of a huge system with lots of dependencies and a very large history of changes, all right? The code here should be understandable even if you don't know Erlang. There are three functions. From the bottom up, evaluate test is a test function that verifies that run, the other function, actually executes the evaluate function. Evaluate just puts the parameter in a tuple and returns it. It's an example of something that may take a lot of time, or it may be complex, called other modules, whatever. But the idea here is to test that the result is different from the input. And then run the function, the main function of the module, calls evaluate, logs the result on the console, and returns it. There is nothing fancy, but again, let's pretend that this is a much more complex thing in a very, very large project that doesn't fit on the slide. At some point in that project's history, the boss comes along with a requirement for an A/B test they want to run. It's a Jira ticket, as you can see, with a very clear description. So let's implement sampling. First of all, we add a sample rate parameter to our application configuration. In Erlang, we can do that in multiple ways. One of the simplest ones is the application environment. So we do that. We add the parameter to the app environment, as you see on the screen. Then we took the existing module and we add the code to sometimes ignore the evaluation based on the parameter we just added. But we all know that test-driven development is the right way to work, so that's how we do it. We write the tests first, they fail, and so we need to adjust the code. If you see the test, basically we have a test for the sample rate being 0, so everything has to be ignored, and another one with the sample rate being 1, so everything has to be evaluated. To do that, to do the actual code, we change the run function so it reads the parameter from the application environment, and just in case it's not there, we provide a default value for it in a macro called default sample rate. But that's not enough for the test to pass. In fact, the code doesn't even compile yet. We need to use the parameter that we picked up from the configuration. For that, we create an intermediate function to sometimes ignore the evaluation altogether based on sample rate and using a random value between 0 and 1. So when the random value is above the rate, we ignore that evaluation, and that's it. We implemented what the boss was asking. The code now sometimes evaluates the requests and sometimes it does not. Very good. Many months, many code changes later, maybe even different developers, different context, everything changed, but we now need to remove the sampling. And the thing is, for whatever reason, we can't just revert the previous commits. Maybe we don't know, maybe we are not sure if something else changed in between, maybe somebody rebased and pushed. Don't do that, but maybe. So maybe we don't even think about the possibility of reverting the previous commit. So we just go ahead and remove the sampling by hand. We are very careful. We don't want to break anything. So our goal is to effectively make the smallest change possible. I guess everybody was in this situation at least once. You don't really know if what you are changing may affect or break other things. So the smallest the change, the better. So starting once again with the test, we remove the sampling pieces. Now the test fails, of course. And that prompts us to remove the part where maybe evaluate returns ignored. This one. And that's it. The code doesn't have sampling anymore. But as you can tell by the fact that it uses 2 columns in the slide instead of just 1, there is a lot of code that was left there, and it's actually not needed. First, maybe evaluate has 3 arguments, and it only uses 1, just to call evaluate. So there is really no need for maybe evaluate at all. Maybe evaluate the other one with 2 arguments can just call evaluate 1. But if we try to compile this code, the compiler will correctly tell us that the first argument of maybe evaluate with 2 arguments is unused. We could mark it as ignored, but we can also just remove it. We will be in the same situation once again. We can remove maybe evaluate altogether. But then the compiler will also warn us about something that's called a dead store. You put something in a variable, and that variable was never, that value was never used, that variable was never used. So it's just there. It's called dead store. It's stored, but not used. Sample rate is an example of just that. So we can just remove the variable with the code associated to it, because if we read something from the environment and we don't put it anywhere, why do we do it? So we remove it. Now the code compiles and the test passes once again. It's far simpler than it was before. Now it uses just 1 column on the slide. That's better. But we can go even further. This macro is completely unused. Nobody consumes it, so we can remove it. And don't forget about the application configuration in the other file, right? We can remove it too. Nice. Finally, we have really removed all the sampling. And now I told you that this example will show you what Oxbow code is. But did you see what it is? Did you see all the extra code that we eventually removed? That's the Oxbow code. That's indeed the technical name for it. And since I find that name super clever, I will show you its etymology. It all started hundreds of years ago, when humans domesticated the ox and started using its services to plow our fields. To keep these animals together and working as we wanted, we developed a U-shaped metal pole that fits the underside and the sides of the neck of an ox, held in place by a bow pin. We call that thing the Oxbow. On entirely unrelated news, the Earth also has rivers that meander, flow in non-linear patterns from their sources to their destination. These river paths, though, are not fixed for eternity, even when they may seem so. Sometimes a river course gets so close to itself that eventually a part of it splits from the river and becomes a lake. Somebody saw that in a map and immediately thought of the Oxbow I mentioned before. You can see the similarities, right? It was then called Oxbow Lake, something that was part of the main flow of the river before, but it's not anymore. Yet it stays there, contributing nothing to the river at all. Like that macro we saw before, which is a remnant from a previous version of the code that even when it may end up reaching production, it contributes nothing to the system it belongs to. It's a very nice analogy, I think. And while nobody advocates for the removal of Oxbow lakes, of course, I guess we can all agree in the benefits of removing Oxbow code. We all intuitively know that less code is easier to maintain than lots of code, regardless of the language. Well, it may depend for Haskell, but for other languages, it's kind of true. Anyway, we can agree that code that is included, compiled, but crucially not run in production is unnecessary. And removing it will reduce the maintainability costs of our software, right? The type of code is called Oxbow code. So, what prevents us from going all the way in all of our pull requests and just always remove all the Oxbow code instances that result from our changes? Well, our example is very simple, but you can figure out what's going on. Can we remove this macro? Well, we stopped using it here, but do we really know if it's not used anywhere else? Even when it was specifically introduced for this thing, when the first issue was taken care of, maybe later somebody else decided to use the macro for something else. So is it safe to remove it? Maybe. Can we remove the setting? Well, again, we stopped using it here, but before removing it, we should check that the whole code base is not using, in the whole code base, nothing is using this sample rate again. What if this function that doesn't need the first two arguments is called from somewhere else? And we break that by removing the unnecessary arguments. In a nutshell, we don't know, or it's not simple to be sure about, the removal of these instances. So, to be sure, we leave those things there. It's safer to leave them there, even if they are not used, than to remove them and leave the door open for unexpected bugs in production. What we need is a tool that will help us detect that stuff, verifying that it's actually super safe to remove it, and that's what I will show you today. In fact, I will show you not one, but two tools that achieve this goal. Let's start with Hank for Erlang. Hank is a river tree plugin. In other words, it's a tool that can be run before compiling your code. It detects and reports Oxbow code instances. It is extensible. It comes with many detection rules baked in, but you can add your own ones. It's accurate. It may not report all the Oxbow code instances, but when it finds one, you can be sure it's a real one, and it's configurable, so you can decide how thorough you want it to be. I will dive deep into each of these characteristics, starting with the rules and the extensibility. These are all the rules that are already baked in for Hank. Let's go one by one. And if you are not an Erlang developer, you can tune out for a few minutes. It will be very, very Erlang specific stuff coming up right now. The first thing that Hank detects are unused record fields. Fields that are defined as part of the record, but never set nor read anywhere. On the screen, you can see that the record called myRecord has two fields, and it's private to the module in which it is defined. A piece of advice, always define records within modules, otherwise they are shared by your whole application, and tracking down the usage of their fields will be far difficult. Since the second field here is not found anywhere in the module, there is really no need to have it there, right? Besides the common maintainability issue we mentioned, that's basically shared by all rules, the less code thing, removing these fields will reduce the memory consumption of the system in production. Each field that's removed removes at least 1 byte for each record entry we have. It's not a bad thing if we use this record a lot. Hank also detects unused macros. In a similar fashion as the previous example, the first macro that's defined in this module is never used within it. Since the declaration is private to the module, we are 100% sure it's not needed and thus it can be removed. Hank also detects unused header files, files that have the HRL extension and are never included in any module. This rule in particular may report some false positives, in quotes, for library apps that contain HRL files that are expected to be included in client apps without ever being used within the libraries themselves. In that case, you can configure Hank to ignore the rule, as you will see later. But my advice is to don't do that. Don't force your users to include HRL files from your library, and even less so if you don't include them and therefore you don't test them in your library. There are very, very few cases where that's the only option, and in general, the other options are better. If you want to know more about this and other good practices I generally advocate for, talk to me after the talk or watch my future talk about beautiful code at CodeBeam London in a week. Moving on. The next rule is for something we saw already, unused configuration option. There are many ways to define and consume an environmental variable for an Erlang application. Hank is very careful to account for all of them, and it will only emit this warning if it is 100% sure that fields, like the second one in the list on the top right, are not used anywhere within the application it is analyzing. And another one we had in the example before, unused function arguments. Functions with one or more clauses that simply ignore a parameter in all of them, like the second one in the function you see on the screen. This rule is very tricky because Erlang has dynamic function calls, so sometimes some functions must have a required arity. They just can't have fewer parameters, like in the case of behavior callbacks, and Hank is aware of most of these situations. The idea is that it only reports unneeded arguments when it is 100% sure that they are in fact unnecessary. And then we reach this heavily opinionated rule. The advice here, and I wrote 2 articles and delivered 2 talks that you can find online about it, is that when you are defining your own behavior, you define its callbacks in the same module where you use them. That's how OTP behaviors are defined, for instance. So if you follow that advice and you have a callback attribute in a module where it's never used, you can be sure that it can be removed. It's not needed. If you don't follow that advice, you can disable the rule, as you will see later. Finally, Hank will also emit warnings about header files that are included in just one module, and so they can be part of the module instead of being out of it. And attributes like macros or records that are defined in a header file but used in a single module. Again, they can be moved to that module directly. This is a very useful rule because by making these kinds of things private, the module where they are used, Hank and other tools like Elvis, Xref, and Dialyzer can more easily and more accurately detect issues within that module. And you can then add your own rules by implementing the Hank rule behavior as you see on the screen. The behavior has only 2 attributes, one to analyze the files, provided an AST with the context, and one to allow users to specify the warnings that they want to ignore, if any. If you are an Elixir developer, instead of Hank, you can use Meandro. Meandro is basically the Elixir version of Hank. You cannot use Hank for Elixir because Hank analyzes source code, and so you have to be able to analyze Elixir code instead of Erlang code. But as I said before, the underlying principles are the same. Meandro works exactly in the same way as Hank, but it is a mixed plugin instead of a River 3 plugin, and it has, of course, its own set of rules. Most of them are the same ones as Hank, exactly with the same meaning, exactly with the same particularities. But there is one that's particular to Elixir. It is unused struct fields. It works very much like unused record fields, but for structs instead. So, can we just remove everything that Hank or Meandro detect? How accurate are these tools? Well, in the Erlang world, there is one super famous static analyzer. It's called dialyzer, discrepancy analyzer. Dialyzer is famous for its accuracy. It may miss some stuff, but it never reports a false positive. Our goal is for Hank and Meandro to have the same level of accuracy. That's the rule that we followed when we built them. And for most of the rules, it has been proven that it is so. But Erlang in particular, and more specifically its abstract syntax tree and abstract syntax tree manipulation tools are, let's say, complex, built for specific purposes that are not exactly what we are doing here. More on that on the table afterwards if you want. And it's very tricky to be as accurate as we want. That's the reason why we need you to try Hank and Meandro and report issues every time you found a false positive. We want to kill them all with fire, of course. But both tools are open source on GitHub, and we are very interested in scaling up their accuracy as much as we can. Let's assume they are super accurate. Even so, sometimes you will want to ignore some of its warnings. Maybe you have different opinions of what constitutes unused code. Maybe you want to keep some unused pieces of code because you grow fond of them. I don't know. Maybe they will be used eventually. Maybe they are part of the code and they are there for some documentation purposes. Whatever the reason. In any case, Hank has a few ways in which you can configure it so it can work as you want. First of all, you can configure Hank for your whole project at once on rebirth config Hank section. There are 3 possible entries there. With rules, you can specify the exact list of rules you want Hank to run on your files. By default, that is, if you don't include this section, Hank will use the default list of rules that you can find in its documentation. The same ones that I showed you before. Here, you can include fewer rules if you don't want to run, say, the unused callbacks one. But you can also add your own ones if you created them. Then you can use parsing style. You can choose between 2 ways of parsing files, sequential, which is slower but more predictable, or parallel, using processes, it's faster. Parallel is the default one, but if you need to debug something, it's usually very convenient to switch to sequential, at least until you report the issue. Then you can go back to parallel. Finally, you can choose some items to be excluded from Hank's analysis. If you don't say anything, Hank will analyze every single Erlang file, or Meandro will analyze every single Elixir file that's present in the folder where your project lives. But you can tell them that some files are not there to be part of the project, or maybe you want to exclude the tests or something. You can do so in a couple of different ways. You can ignore files or groups of files entirely using wildcards, like you see on the screen. And then you can also ignore only certain specific rules in certain files, letting Hank run the others normally. Or for each rule, you can ignore specific elements. For instance, for record fields that you can ignore warnings about a particular record, maybe a particular record field, etc. That's what the goal of the ignore callback I showed you before is. And to make it even more convenient, you don't need to specify all those options in the configuration file. You can also add ignore rules directly into your Erlang files. In other words, you can put the ignore attribute next to the thing you want to ignore in Hank. Of course, Meandro has its own similar options, actually the same options, and the similar ways to specify them only in Elixir terms. And why is this important? Because these tools are meant to be used in very large and old code bases. More often than not, cleaning an entire project at once is not feasible. It's a humongous task. So to do the cleanup iteratively, you first need to ignore a lot of things, and then progressively remove the ignores and the associated Oxbow code until everything is clean. Now, these tools have been around for a few years already. And as somebody pointed out in the conference talk submission, how well they work, right? Have they been tested? For starters, when Laura and I wrote the paper associated with Hank, we faced this same challenge. We wanted to see how effective and accurate it could be. For that, we needed very large, somewhat old code bases. And the first one was the obvious one, OTP itself. The oldest Erlang repository in the wild. We found many unused macros, and we found unused record fields, unused function arguments, and even an unused configuration option. Then we tried with one of the largest open source Erlang projects from GitHub, Kazoo. The results were not as impressive as the ones for OTP, but still, there was quite a lot of Oxbow code that could be removed. And it's worth mentioning, Kazoo uses macros and parse transforms extensively. That reduces the surface that Hank can analyze, while retaining its desired level of accuracy. So even in that situation, Hank was able to find a lot of things. Finally, we checked one of the cleanest Erlang systems out there, Mongoose IM, by Adam Solutions. I personally knew that system since I had contributed to it in the past, and I know the people that manages it and how focused they are on maintainability. So we assumed that Hank was going to find very few Oxbow code instances there. Nevertheless, we found 90 unused macros, right? Not bad. Even in the most carefully maintained systems, there is Oxbow code. So, are these tools useful? I would say yes. But are these tools used? We did the previous analysis almost 3 years ago. So, how are they doing today? Well, since the time we created Hank, I moved to a different company. I currently work at Baxter. That company was Nextron. Hank and Meandro are both open source projects from Nextron. So I know that Hank and Meandro are currently used by Nextron itself, of course, and Baxter, where I work now, and many other open source projects in GitHub. And of course, they are not the most popular plugins on HexPM, but they are downloaded and thus used more than 1,000 times each week. And remember that these things, particularly using River 3, are cached in your computer. So it's not like you download it every time you compile a project, right? It's not bad for static code checkers. And now what? Hank has reached production state a while back, but there are still many things that can be done. For starters, Hank and Meandro can be used as an inspiration to write similar tools for other languages. Very, very few Oxbow code detectors exist today. When we wrote the paper with Laura, we looked for them and we found kind of one for Python maybe, and a very old one for Java. So if you're attending this conference and you feel like improving the lives of your fellow language developers, maybe you can consider writing a static code checker that helps them remove unnecessary code. If that's up your alley, talk to me or Laura afterwards. We will be very glad to help you and guide you. And maybe you end up with another academic paper like I did. Who knows? On the other hand, Hank and Meandro can be improved with more rules, with better AST parsing, with better or more performant internal processes. We welcome performance improvements with open arms. Since these tools are more effective when run on large code bases, their execution may take a while. It's usually as fast as Dialyzer, which is a good thing, but still it may take a couple of minutes to run on a large project. So it's nice if we can trim down those times as much as we can. We the maintainers, are not the most experienced performance improvement, developers you can find out there. So if you like, there is a lot of field to work on there. Finally, as I said before, give us all your false positives. Scaling up accuracy is one of our main goals, for sure. So what we have learned today, or what I hope you have learned today, what is the TLDR? Hank and Meandro are static analyzers for Erlang code and Elixir code that detect and report instances of Oxbow code with a high degree of accuracy. You can use them, contribute to them, or consider them as an inspiration to write similar tools for your favorite languages. Thank you very much, and before I go, I need to mention all the people that contributed and contributes today to these projects. Folks from Ficus and Nextdoor that created Hank and Meandro with me, Mackenzie, the author of Meandro, the actual maintainer of it too, folks from the community like Pablo and Laura that are the main contributors to the project, even if they were not part of the original team that created it. Of course, Nextdoor, amazing company, which provided the time for its developers to regularly maintain these open source initiatives, and the Erlang Ecosystem Foundation that helps promoting them in many ways, such as this very talk you're watching right now. And finally, you. Thank you for watching and becoming users of these humble tools that may improve your life and the lives of others like you.
There's one question.
Yeah, I can answer quickly.
Sure.
Okay, so the question is, what are the main difference between Hank and Dialyzer? They are both static analyzing tools. That means they run on your code, that's fine. But the different thing here is that Dialyzer focuses on figuring out where pieces of your code will run and fail, crash in production. And Hank focuses on finding pieces of code that will not even run in production. Whatever Hank detects, if it reaches production, there is no way the code will go through it. On the other hand, for all the code that Hank doesn't report, if you run the Dialyzer on it and it finds a warning, that means that when in production something goes through it, it will crash.
So that's about it.
Thank you.
Sure. Thank you so much for the session, Brujo. Thanks a lot.